What if the newest data on 3I/ATLAS isn't just unusual, but flat out impossible? Because a fresh scientific report just revealed something so extreme that even the researchers studying it can't agree on how it's happening. And the strangest part, the more they try to explain it, the more the explanation breaks apart. We're talking about a chemical signature so off the charts, so far outside anything ever seen in a natural object, that it forces one uncomfortable question. What exactly are we looking at? For months, 3I/ATLAS has been defying every rule of comet science. But this new discovery? It takes the mystery to a level that's almost unbelievable. And if the numbers are real, then they may point to something no one is prepared for. Let's break down the anomaly that scientists can't explain, and the one detail that might change everything we thought we knew about this object. The first red flag shows up the moment scientists looked at 3I/ATLAS's chemistry. In every normal comet we've ever studied, methanol makes up a tiny fraction of the total water, usually somewhere between 1 and 5%. It's a predictable ratio, something you expect to see in cold, natural objects drifting through space. But 3I/ATLAS doesn't play by those rules. It barely has any water at all, just 4%. That number alone is strange enough to get attention because you can't compare methanol to water when the water is practically missing. So the researchers tried something different. They compared the methanol to hydrogen cyanide, a substance that's already unusually high in this object. And even using that benchmark, the methanol shot past every limit. It wasn't just a little higher, it was 79 to 120 times more abundant. That's the kind of number that makes scientists stop mid-sentence. Now imagine if they had used the traditional comparison with water. We wouldn't be talking about a small deviation. We'd be talking about levels roughly 800 times what a natural comet should carry. 800. A number so extreme that it doesn't just break the chart, it erases it. And this was only the beginning. Because once this result showed up, it forced researchers to confront a bigger, more uncomfortable question. If the chemistry doesn't behave like a comet, then what exactly is producing these impossible ratios? When scientists realized the methanol numbers were out of control, they quickly pointed to a past example. The Comet C/2006 R2 Pan-STARRS. On paper, it sounds like a reasonable comparison, a comet that also showed unusually high methanol levels. But this is where the half-truth starts creeping in, because Pan-STARRS wasn't actually rich in methanol at all. It only looked that way because it barely had any water. When the denominator shrinks, the ratio shoots up. That's all it was. The raw amount of methanol in Pan-STARRS was completely normal. Nothing extreme, nothing explosive, nothing close to what we're seeing now. But 3I/ATLAS flips that logic upside down. Its methanol isn't high because the water's low. Its methanol is high because the methanol itself is off the charts. This isn't a proportional trick. It's an absolute overload. It's like standing in a room full of very short people and suddenly seeing someone who looks tall versus standing in front of an actual giant. One is a visual illusion. The other is a reality you can't ignore. And once you understand that difference, you start to notice something else. The scientific comparisons aren't clarifying the mystery. They're trying to soften it. Because the truth behind the numbers is far stranger than any quick reference to Pan-STARRS can explain. But the moment scientists tried to justify this massive chemical gap, their explanation raised even bigger questions. The moment researchers were pressed to explain these extreme methanol levels, they reached for a familiar escape hatch. Maybe 3I/ATLAS formed in a colder region than our comets. On the surface, it sounds reasonable. But once you look at the actual temperatures involved, the entire explanation collapses instantly. Our comets already form in some of the coldest places nature can offer. The Oort cloud sits between 3 and 30 Kelvin, just a whisper above absolute zero. The interstellar medium, about 2.7 Kelvin. We're already at the bottom of the cosmic freezer. So when scientists suggest that a difference of roughly 1 degree colder could somehow generate methanol levels hundreds of times higher than anything ever recorded, the logic doesn't just stretch, it snaps. It's like claiming someone grew into a giant because they took a shower 1 degree colder than everyone else. It sounds scientific until you think about it for more than 3 seconds. And that's the problem. The cold formation idea doesn't actually answer anything. It just moves the mystery around without solving it. Because if temperature alone can't create these impossible chemical ratios, then something else must be shaping the composition of this object. And that something else leads to a possibility researchers refuse to even consider. There's an unspoken rule in comet research. No matter how bizarre the data gets, the explanation must stay natural. And with 3IAtlas, that rule has created a blind spot so large it's impossible to miss. Because while scientists scramble to fit these impossible chemical ratios into familiar theories, they completely ignore a possibility sitting right in front of them, the artificial hypothesis. Methanol isn't just some random space chemical, it's a fuel, a powerful one. Engineers already consider it a candidate for future spacecraft because it stores well, burns efficiently, and can be produced by biological processes. Yes, biological. Fermentation, something you'd expect to see in a lab or a living system, can generate methanol in huge quantities. So we now have an interstellar object carrying levels of a potential spacecraft fuel that border on absurd, and absolutely no one in official science finds that unusual. It's almost comical. The data screams that something is different, and the response is to double down on explanations that barely hold together. As Dr. Avi Loeb famously said, comet experts see comets the way an AI trained on a single dataset sees the world. No matter what you show it, it will try to classify it as a comet, even when the evidence points somewhere completely unexpected. And the moment you question those assumptions, you start noticing other anomalies that science keeps brushing aside. Just when the chemical anomalies were already hard enough to swallow, something even stranger happened. Dr. Avi Loeb reached out to NASA's Jet Propulsion Laboratory, asking for clarification about 3IAtlas's non-gravitational acceleration, the sudden, unexplained push this object experienced. NASA's answer? Silence. No explanation, no discussion, nothing. But what they did instead is far more revealing. Without addressing the question, NASA quietly modified the official data. Originally, the trajectory showed 3IAtlas passing 53.5 million kilometers inside Jupiter's Hill radius, the zone where the planet's gravity dominates. That position would have put the object on a path perfect for releasing probes into the Jovian system. Then the update appeared. Now the object is listed as passing 53.587 million kilometers outside the Hill radius. A tiny numerical shift, but one that completely changes the interpretation. NASA claims they simply refined the data after realizing the acceleration was smoother and more gradual than expected. But Loeb, who's reviewed thousands of trajectories, strongly disagrees. According to him, the acceleration wasn't gentle at all. It was sharp, sudden, and nearly impossible to miss. In other words, it looked intentional. And here's the part nobody mentions. The statistical chance of 3IAtlas passing exactly at the boundary of Jupiter's Hill radius by pure coincidence, 0.004%, practically zero. The kind of number that raises eyebrows, even if you're trying not to. A trajectory that precise, combined with an unexplained acceleration, doesn't look random. It looks calculated. And this calculation points to a purpose far bigger than anyone expected. Once you put all the pieces together, the path of 3IAtlas stops looking like the wandering drift of a natural comet and starts resembling something far more deliberate. The object isn't just skimming past Jupiter. It's positioning itself at a location that would be ideal for any kind of controlled operation inside the Jovian system. Exploration, surveillance, deployment, retrieval. Take your pick. The geometry fits all of them. And that brings us to the part almost no one talks about, the strange signal detected on Ganymede not long ago. At the time, it was brushed off as noise, a glitch, or an unexplained blip. But now, with a mysterious interstellar object approaching the perfect insertion point for interacting with Jupiter's moons, the coincidence becomes harder to ignore. If 3IAtlas isn't behaving like a comet, and the data clearly shows it isn't, then its trajectory starts to look like something else entirely. A maneuver, a path chosen for a purpose, a route you'd expect from a civilization capable of crossing the gulf between stars. And here's the part that makes the whole thing even more unsettling. If its path is intentional, then so is its timing. Because 3IAtlas isn't just passing by randomly. It's arriving at a moment when we have the technology to observe it, question it, and track every strange detail, almost as if we were meant to see it. But if this really is an engineered object, then the technology behind it would make our most advanced systems look primitive. If 3IAtlas is artificial, then whoever built it isn't just ahead of us. They're operating on a scale we can barely comprehend. To understand the gap, you only need to look at our own evolution. 40 years ago, the most advanced mobile device on Earth was a plastic brick that could barely make a call. Today, we carry foldable computers in our pockets that can translate languages, process millions of operations per second, and send images across the planet instantly. That's the leap we made in 4 decades. Now imagine a civilization with a 1,000-year head start, or 10,000, maybe more. Their technology wouldn't just outperform ours, it would look like magic. We wouldn't even have the vocabulary to describe what we'd be seeing. This could explain everything about 3IAtlas, the impossible methanol levels, the non-gravitational acceleration, the razor-thin trajectory near Jupiter, and the quiet data updates that follow every new anomaly. If the object is using propulsion methods we've never conceived of, chemical, biological, or something completely unknown, we wouldn't recognize them any more than someone from the 1800s would recognize a smartphone. And that's what makes this so unsettling. Because once you accept that possibility, every anomaly stops being an accident. It becomes a signature, a fingerprint of something designed, not formed. But the most alarming part? These anomalies aren't slowing down, they're increasing, and the next one could be the hardest to ignore yet. But here's where things get even more shocking. Astronomers analyzing the gravitational influence around 3IAtlas noticed a strange delay, almost like the object was responding to something or waiting for something. Objects traveling at interstellar speeds don't slow down unless forced to. So the real question is, what could possibly make an interstellar anomaly pause its trajectory near our solar system? Some researchers believe it might be reacting to Jupiter's magnetic field. Others think it's aligning itself for a maneuver. But a bold new theory suggests something far more unsettling. 3IAtlas might not be acting like a comet at all, but like a probe. Because if an object can change direction, if it can release synchronized jets, if it can mask its heat signature, then we're not dealing with a natural visitor. We're dealing with something engineered, something designed for long-distance exploration, and maybe surveillance. And as NASA prepares new instruments to capture the next data burst from this mysterious traveler, one thing becomes clear. Whatever 3IAtlas is, it is not behaving like anything we've ever seen. And the next update might be the one that changes everything we know about interstellar objects. After months of observations and countless anomalies, one thing is undeniable. 3IAtlas is unlike any comet we've ever studied. Record-breaking methanol levels, non-gravitational acceleration, metallic composition that doesn't match known celestial bodies. A trajectory that aligns too perfectly with Jupiter's Hill radius, even NASA's quiet data updates. Each anomaly alone might be dismissed. Together, they form a pattern that is hard to ignore. And that pattern points to a question that no one can fully answer. Are we looking at a natural object, or a piece of technology from another world? As 3IAtlas approaches its closest point to Earth, astronomers will watch closely for missing gases and unexpected behavior. If the results continue to defy natural explanations, we could be witnessing humanity's first confirmed encounter with interstellar intelligence. The countdown is on. And one thing is clear: the universe might be far stranger than we ever imagined. What do you think? Could these anomalies be a coincidence, or are we finally seeing proof that we are not alone in the cosmos? Comment your thoughts below and stay tuned, because this story is far from over.